Hello everyone, here's a little video about graphing using transformations. So in general, there are three types of transformations. We have our reflections, we have our stretches and shrinks, and we also have our translations. There are two types of reflections. You can either move over the x-axis or over the y-axis. There's two types of stretching and shrinking. You can either stretch or shrink vertically, which changes the y values, or horizontally, which changes the x values. Okay. And there are kind of two types, but four directions of translations. You can either go up, down, left, or right. And when you do that, you're going to be moving the whole graph up, down, left, or right. Okay. So let's get into some examples. Okay. So first, we're going to look at this parabola. So we're going to look at what kind of things it has. So to start with, it does have a reflection. Okay, so because the negative is on the outside, right, and in general, outside things happen to y values. Okay, so for us, that means that our y value is being replaced by a negative y. That's what that negative sign means, which also means you're going over the x-axis. Okay, our second thing is that we do have a number being multiplied in front. So all y values are going to twice as big. Okay, so it's a stretch vertically by 2. Right, or 2 times as big. And then for translations, we actually have two types of translations. The +3 on the inside goes to the left. The +1 on the outside goes up. So it goes left 3 and up 1. Okay. Now, in order to graph these, we're going to have to use steps, right? So we have three types of transformations. We're going to have 3 steps. Okay. Now, before I even get there, I'm going to have to graph an x squared. So in order to do that, I kind of plot my important points. And so the most important one is going to be right here at 0, 0. And then 1, 1. Negative 1, 1. And then if you want to, you can go a little bit farther out, okay, to those 4 points. Okay, this is my parent function. It's not my final answer, so I tend to use a dotted line when graphing it. Okay, but I am going to label it. This is graph number 1, right? That's my parent. That's where I start. Okay, now our first type of transformation is a reflection, so I'm going to do that next. So every one of these points gets moved to a negative y value. Okay, so this point here was at 1, is now at negative 1. Okay, the point that was at 4 is now at negative 4. Okay. 0 is a special case because 0 times negative 1 is still 0. So that point ends up being exactly the same. And again, this is not my final answer, so I tend to draw it with a dotted line. If you use colors, you don't really have to do dotted lines. It's up to you. Okay, so there we go. We have our first part of showing our work, which is showing our reflection. Okay. Next up, it says I'm going to stretch by 2. So every y value goes to 2y. So this y value right here, which is at 1, is now at a 2. Okay, negative 1 to negative 2. Same thing on this side. 0 times 2, still 0. Okay, these ones, 4 times 2 would be all the way at negative 8, which is a little too big to graph. So you kind of graph it as best you can. Make sure you go through the points that you actually know about. That's going to be our third line. And then last but not least, we are graphing our movements, our translations. So it says every point needs to go left 3, so 1, 2, 3, and up 1. So there's my center point, okay? And you can do it to every single point. So you can go right here to this point and say, I'm going to go 1, 2, 3, up 1. Draw a dot, okay? This one you go 1, 2, 3, and up 1. Okay? As kind of a check that you did it correct, the point next to your center point, or your 0, 0 point, should have kind of like a linear slope. So for us, we had a -2 out in front. So from the center, we should be going a slope of -2 to get to the next point. And that's just a little mental check for you. It's not actually a straight line since it's a parabola, so it curves. Okay. And then you draw your dashed line. And I'm going to label it. That's graph number 4. Okay, so there's my final answer. I did every single step, and I have my final graph. Oops, sorry. I'm going to do one more example for you. So this one's a little bit different. This is a square root function. And again, I'm going to list what it goes through. Okay. So for this particular function, I do have a reflection. My x got switched for a negative x, which means it goes over the y-axis. Okay. I do still have a 3 on the outside, so all my y values are now switched to 3y. And I have one translation I'm going down to. Okay. So again, to start my graph, I'm going to draw my parent function. Here is a parent square root function. Okay. And then I'm going to do each of those things. So the very first thing was to do x for negative x. Okay, so every x value gets turned into a negative x. So if I start at my farthest away point there, that x value is 4, right? It's 4, 2. So now I am at negative 4, 2. 1, 1 becomes negative 1, 1. 0, 0, well, 0 times negative 1, still 0, unfortunately. Okay. Next, I'm going to move on to my stretch. So it says all y values become 3 times the y value. So my origin, 0 times 3, still 0. 1 times 3 becomes 3. 2 times 3 becomes 6. Okay. I am going to put it there just because 2 points is kind of not enough to show the shape. And then again, right, trying to make it through all my dots. Okay, there's my third graph. And then last but not least, it said everything should go down 2. So my very final graph is I'm moving each of these points down 2. And then this 0 now also goes down 2. Okay. And that is my final graph. Okay. And then just for good showing work, I am going to still label which one came first, second, third, and fourth. Okay. And that's the end of this square root function. If you have any questions, feel free to email me. Okay. Otherwise, have a happy weekend.